Hello everyone, in today's video I am going to discuss some more types of matrices. Regarding this also some question comes in CSIR NET and that is why I am covering this topics also. And for more learning, please subscribe to my channel. So the first type of matrix is the orthogonal matrix. Any matrix is said to be an orthogonal matrix if A into A transpose is equals to I. Okay, where A is any matrix. So for example, if I take A to be 1 0 0 1, then A transpose is equals to again 1 0 0 1, then A into A transpose is equals to 3. This is first row into first column 1 0 0 1. See, this is again the identity matrix. So here this A matrix, that is 2 cross 2 identity matrix, is an orthogonal matrix. Okay, so there are some properties of orthogonal matrix. Let us see those properties. Okay, so see, if A is an orthogonal matrix, then A is non-singular. Okay, non-singular, and A inverse is equals to A transpose. Okay, so A is non-singular means determinant of A, see here, determinant of A is not equals to 0. Okay, next, determinant of A is equals to plus minus 1. If A is any orthogonal matrix, then its determinant is going to be plus or minus 1. Okay, next, the transpose of an orthogonal matrix is an orthogonal matrix. Okay, transpose of an orthogonal matrix is orthogonal. Okay, next, the product of two orthogonal matrices is also orthogonal. Okay, product of two orthogonal matrices is also orthogonal. Next, see, next is inverse of an orthogonal matrix is also orthogonal. Okay, now these are some of the important properties that you need to remember. Okay, now the next matrix is involuntary matrix. Okay, so a matrix is said to be involuntary if A square is equals to I. Okay, where I is the identity matrix which is having the same order as that of A. Alright, so let us see one example of this type of matrix. So let me take an example. Let A be equals to 1 0 1 minus 1. Okay, so now A square is equals to how much? 1 0 1 minus 1 into 1 0 1 minus 1, which is equals to, say, this is first row into first column 1, again this is first row in the second column, that is 0, and this one is second row into first column, that is 1 minus 1 0, and this is second row into second column, that is 1. Okay, so what we got, it is I, isn't it? That is the identity matrix of order 2. So here the identity matrix is always an involuntary matrix. Okay, so here identity matrix is always an involuntary matrix. So the next type of matrix is the companion matrix. Okay, so here see this one 0 0 0 up to minus, this is A0. Now this is 1 0 0, this is minus A1, then 0 1 0 minus A2, and so on up to 0 0 1, and this is minus A minus a n minus 1. Okay, minus of a n minus 1. So here this is the n cross n companion matrix to the monic polynomial, to the monic polynomial a of x is equals to a0 plus a1x plus a2x square up to a n minus 1 into x to the power n minus 1 plus xn. Okay, so if this is a monic polynomial, then its companion matrix is given by this. So the rule for writing a companion matrix is the last column. Here in the last column we will write minus of a0, a1, a2 up to an minus 1, and the first row before this will contain 0, and the rest of it is the identity matrix. Okay, so this is the rule for writing the companion matrix for such type of polynomial, that is monic polynomial. Here monic polynomial means the polynomial should be of one variable and the coefficient of the highest degree, that is the highest power of that variable, should be 1. Okay. For example, see, if this is a monic polynomial, 30 cube minus 2t square plus 6t plus 5, then its companion matrix is going to be, say, here we will take the coefficient only up to an minus 1. So this is going to be a 3 cross 3 matrix. See, 1, 2, 3. Only 3 coefficients are going to be there. So this is a0. Hence this is minus of 5. See, minus of a0, that is minus of 5. Then minus of a1. This is a1. So this is minus 6. And then minus of an minus 1. This is the nth degree, that is n is equals to 3, and here n is equals to, sorry, n minus 1 is 2. Okay, so its coefficient is minus 2, and minus of minus 2 is 2. So here this is 2. Now the rest, the first row, the elements of the first row will be 0, and here the rest elements will be in the form of identity matrix. Okay, that is 1 0 0 1. Okay, so this is the companion matrix of this monic polynomial. Alright, now the next type of matrix is the permutation matrix. Okay, so any matrix whose elements are either 0 or 1 and the sum of each row and column is equals to 1 is called a permutation matrix. Okay, for example, see, if we take 1 0 0 1, then here we can see the sum of this row is 1, the sum of this row is also 1, the sum of this column is 1, and the sum of this column is also 1. Okay, so this is a permutation matrix. Now another 2 cross 2 matrix which is a permutation matrix is 0 1 1 0. Okay, here also the sum of each column and each row is 1 1. Okay, so therefore this is also a permutation matrix, and also the elements of these matrices are either 0 or 1. Okay, next let us see the examples of a 3 cross 3 permutation matrix. Okay, so these are the examples of 3 cross 3 permutation matrix. Okay, of 3 cross 3 order. Okay, see here, the sum of each row and the sum of each column are 1. Say 1 1 1. Each row sum is also 1, and see, the sum of each column is also 1, and the entries of each of these matrices are either 0 or 1. So therefore these are all the permutation matrix. Okay. So now see, the next type of matrix is the strictly upper triangular matrix. Okay, an upper triangular matrix with zeros along the diagonal is known as a strictly upper triangular matrix. See, we know that here 1, 2, 3, 0, 4, 5 and 0, 0, 6. This is an upper triangular matrix. Okay, so now when this matrix is like this, say 0, 2, 3, 0, 0, 5 and 0, 0, 0, then this is known as a strictly upper triangular matrix, because here the elements along the diagonal are 0. See? So this was all for today, and if you like this video then please to like, share and subscribe my channel. Thank you.